Are you confused about how to use the new Unity input system and don't see why it's a better choice than the old system? Well, you found the perfect video because the new input system can do a lot more than the old one can. Most prominently is, button presses can fire events instead of needing to listen for when we press them inside of an update method. And that's where our video begins. Hello and welcome back to Coding with Unity, where I teach you how to create and develop with Unity3D. The first thing we will discuss in this video is how we will be sending the data from Unity's new input system to the methods that want to receive the data. One way we could do this is with the included player input class, where we can use the Unity events to send the context of the input to another method. But in my example, our methods will be held in their own classes, and we want a single place to check for the input data, while also being able to create multiple versions of the input class. This way, the player and the AI can use the same methods with different executions. So we won't be using the player input class that's provided with the package, and instead, we will be using interfaces and a type of strategy pattern to send the input data to the classes that need them. And by interfaces, I don't mean Unity's user interfaces. Interfaces are blueprints that can be applied to a class. You might be thinking that's the same thing as an abstract, but with abstracts, you can only inherit from one class, and with interfaces, we can inherit from multiple. So for example, our chess script has an IOpenable and an IInteractable interface. That way, when we press the interact button, we can just call chess.interact. Then inside this script, when the interact method gets called, we will fire the open method that's provided with the IOpenable interface. We could also have an NPC that has chat dialog that gets fired through its inherited IInteractable interface. Then say, if we have an event that happens in the game where all objects with doors on them fly open, we can use findObjectOfType, IOpenable, and open all of the objects without having to know anything about if they also use IInteractable. So, hopefully, you can see how that makes our objects a lot easier to create as we continue to build out our game. And we will use the same idea on our player and enemies for receiving the data from the input scripts we will create. And as for the strategy pattern, well, that's a way to have multiple forms of a single method execute. So for example, if every time we press the A button, we wanted to perform an interaction, we could make an interactable class. But what if while we are swimming, the A button makes you swim faster? Swimming and interacting don't really have anything in common, and putting both that logic in the same class would be confusing. So we can make a swim faster class and use the common execute method inside both classes as the method that fires when you push A, which is how we will be using the strategy pattern. I should also point out, with just a little modification, you can technically turn this into the command pattern by adjusting how some of the executions work and having a command processor for passing in the commands each time they get executed and keeping track of them. But that's something for you to research on your own. I believe Jason has a good video on it. Before we get started programming, I just want to point out, I'm not making this video to show that this is the best way to use the new input system, but to show it's a way you could use it, and by doing that, it will hopefully give you ideas on how you can use it. Depending on your project's needs, the implementation you require for your input system may look drastically different than mine. Okay, now that we got that out of the way, let's open up Unity and see how we can implement this. Let's go ahead and create an input script and make our player interact with something when the user clicks their mouse or presses the A button on a gamepad. Alright, now that we're inside of Unity, you can see I have a character set up, a chess set up, and 3 other characters in the background set up. And here's my game display. I already have a camera set up on the character to follow. To do that, I'm using Cinemachine, which is right here. Then you can see our OSRS character just has a transform component, an animator component, a rigid body component, and a capsule collider component. So we want to be able to get our character to move around when you push inputs on your keyboard or on a gamepad like an Xbox 360 controller. And since we'll be using the new input system, we'll need to go to Windows and Package Manager, then look for the new input system. So search for input system. If it doesn't show up, just go to Advanced, Show Preview Packages, and it should show up. let's install it into our project. After getting it installed into our project, we can go to our project settings. Now let's locate where we can select which input system we are using, which you can find in Project Settings, Player, and scroll down until you see Active Input Handling. Currently it's on both. Feel free to leave it on both if you want to use both input systems, but I'm going to switch mine to the new one, so it forces me to only use one of them. Clicking Apply will reload your editor. Don't worry, just give it a minute to reopen. Once we've reset up our active input handling, we can now figure out how to actually get the input onto our character. So if we go to the documents, we can go to the section on creating actions. Here it shows us the action editor that we can use to create our input map, which they refer to as action map. You can see we can make a player input, UI input, and various other ones. That's pretty useful. We can have like WASD, arrows, look, fire. That's pretty much what we're going to be doing, but a little different. And they're using the delta pointer. Delta means it'll give you the data of the direction your mouse is moving in. And because of how our camera is, we're going to use position so that we can get where our mouse is on the screen and get the angle between our character and the mouse. We can then use this map inside of a mono behavior by saying public input action, fire action, which will give us the same action map directly onto our mono behavior that we create. But then that would mean we need to set up one for each character, which could be useful for some games, but we're not going to do that. Instead, we're going to take the name of the action map that we created inside of this editor, and we'll create a new copy of that inside of our mono behavior instead of the base input action class. If we scroll down a little further, you'll see it says you must manually enable and disable actions and action maps that are embedded in mono behaviors. So we'll have to make this enable and disable call, and we'll also have to add the functions to our actions. If we keep scrolling down, you'll see a whole bunch of other stuff you can do with inputs, but we're going to keep it relatively simple in this video. So let's go try to repeat this inside of the editor. Going back into Unity, we can first open up the input editor. We'll right click in our project, go to create input actions. Then we can name it. I'll call mine player input actions. Then we can go over to our inspector and click on edit asset, and it'll bring up our input action editor. We can just dock it somewhere in our window so it's easier to get to. We'll put it down here next to where our console is. And then on here, let's create an action map. We'll call this one our player action. Then we need to create the actual actions here. So our first one is going to be called movement, and the action type will be a pass-through, and the control type is going to be a vector2. This means that the value that this action will return will be a vector2. Then if we go to bindings, we can delete this binding, click this plus right here, and add a 2D vector composite. We'll call our first one WASD. Then it'll be a 2D vector and digital normalized. Digital normalized means it'll return 0 or 1, nothing else. So for the up button, we can go to path, listen, push W, click the W keyboard, and then do the same going down with WASD. Now we can set up another action map under the movements actions for the arrow keys. So let's click the plus button again, add another 2D vector composite. We'll call this one arrow keys. Then we'll use the up, down, left, and right arrows. So path, listen, up, down, left, and finally right. Now let's set up one more for our gamepad. So we'll say plus, 2D vector composite. We'll call this one gamepad. Then if you have your gamepad plugged in, go ahead and grab it. And we can do the same thing. So click on up, path, listen, push up on your joystick, left stick up, and then keep doing the same thing. Excellent. Now we have our gamepad set up with left stick up, left stick down, left stick left, and left stick right. We can minimize these so we have more room to work. And we can also minimize this because we're done with the movements, and we're going to add another action. Oh, I guess when you push plus, it expands everything. How unuseful. Let's rename this action to interact. This would be the buttons we push for interacting. So we'll do the left button and the A button on our Xbox controller. So we'll do the left mouse button and the A button on our Xbox controller. And the interact type is going to be just a button. We're also going to add press and release so that we can know when we pressed it and when we released it and if we're currently holding it down. And the way we'll do that is by going to interactions, click this little plus button, then we're going to add press. Then from press only, we'll say press and release. You can change your press point by clicking open input settings, but I'll leave mine at the default. Now for our interact bindings, our first one, the path will be the left mouse button. So for this one, the listen doesn't work, which I guess kind of makes sense. So you can just go to mouse, left button. Then let's add another one. It's just going to be a normal binding, path, listen, click A on your controller or whatever you want the button to be on your controller. Just click button south so it'll work for every controller. At least that's my assumption. Now we can add our next action map, which is going to be the analog aim action map. So as you can maybe able to tell from the name, this would be aiming with our gamepad. Let's delete this binding and we'll change the action type to be a pass through and we'll pass through a vector 2. Then the same way we set up the gamepad before, let's add a 2D vector composite. We'll name this gamepad and then set up the bindings for your aim joystick. So listen, up, right stick up, down, listen, down, right stick left, and last but not least, right stick right. Now let's set up another one for our mouse aim. So we'll be able to aim with our joystick or our mouse. The reason we aren't putting them under the same thing is for various reasons. You'll be able to see better once we get to the code. So we'll say mouse aim, and then the binding is going to be a position. So we'll go to path, and then just click on position. And then if you click on mouse aim again, we need to change it to a value, and it's going to be a vector 2. Pass through probably works also, but I'm using value. For some reason, it's added this press interactions to our analog aim and our mouse aim also, so make sure you remove that if it added it to yours. That's got to be a bug. It copied it when I clicked the plus button for some reason. And I am getting an error in the console, so maybe there is a bug going on. But it's okay, everything's working fine. No need to be worried. We'll just ignore it. The last one we need to set up is our skill actions. So we'll call it skill, and we're going to pass in the space button on our keyboard. So say listen, click space, space keyboard, and the skill is also a button, so you don't need to change that. Click plus again, add a binding, path, listen. I'm going to click the X button on my Xbox controller, which is button west. Now that we have our action map completely set up, make sure you click the save button. The star right here means it's not saved, so we need to save our asset. After you save the asset, go to the inspector, click generate C# class. You can change where this gets located at if you want to. I'm just going to leave mine outside of all the folders. You could also put it inside of using my folder structure. You could go inside entity and maybe inside of scripts because it's an entity script. Or you can make another folder for player and have a player specific folder for only player scripts. But I'm just going to leave mine inside of assets for now. So once you hit generate C# class, click apply and it'll generate the class into the area that you specified. We have this auto-generated class. It says generated automatically, and now we can use this to create a new copy of it inside of our mono behavior that'll have all the data of this action map that we just created. So let's figure out how we can use this. Well, on our player character, which we can rename to player, that'll make more sense, right? On our player character, we can add a component, and we're going to create a new component. I want to name it player input, but they have a player input and a player input manager. And in my other project, it works fine, but that's because I namespaced it. So it's probably better not to name it player input, so we'll name it something else. But I'm not going to add the component here because adding a component here puts it in your default location in your assets folder, which makes it really easy to start to get unorganized. So let's go into the correct folder to add it. We'll go to input test, entity, scripts, mono behaviors. You'll see we already have an animation controller script in here. We'll get to that later. So inside of here, right click, create C# script, and we'll call it character input since Unity decided they'll take player input from us, which like I said, doesn't really matter if you use namespacing. So let's add this file to our character and open it up inside of our IDE. First thing we'll do is get rid of our start and update functions. Then we'll put it inside a namespace. If you are using JetBrains Rider, we can just hit Alt Enter, click Move to Namespace. We'll put it inside the same namespace as the folder that it's inside of. So input test, entity, scripts, mono behaviors. We know that the character input script is a mono behavior that probably goes on an entity. And inside of this class, first get a copy of that player input actions map that we just created. So we'll say private player input actions, and I'll call it underscore input actions. Now we need to create a new copy of this. So inside of our awake function, I'm going to say underscore input actions is equal to new player input actions. Now, as we saw inside of the documents, we need to make an onEnable function to set up which method is going to call when we push which button. You don't have to do it in onEnable, you could do it in start or awake, but putting in an on enable makes sure we deregister and registers the callbacks that we want to perform correctly. So we're going to say _input actions dot player, and the first thing we're going to set up is the interact action. So we'll say dot interact dot perform plus or equal to, and we need to set up some type of callback context. The way we'll do that is by clicking enter a few times to give us some space to work, and we'll make a new method called private void, because it's going to return nothing, on interact button, because this is the method that's going to fire when we push the interact button. And because we're adding the on interact button to the end of performed, we need to get the callback context inside of the header of our method. So we'll say input actions dot callback context. We can make an open and close bracket, and then inside of here we need to get the value of if we're pushing the button or not. So we'll say var value is equal to context dot read value, and the value type is a float. You might think it's a boolean for am I pushing it down or am I not pushing it down, but it's actually a float for how far are you pushing it down. So now we want to add the on interact button to the end of our input actions player interact.perform. So every time we push our interact button, it's going to call the on interact button and set this value to the float percentage of how far we're pushing it down. Now we also need to make an on disable function for removing this action in case we disable the script. We don't want to have actions loose in memory that could possibly cause errors. So we'll say on disable, and then we'll just minus or equal instead of plus or equal. And then whenever we enable it again, it'll add itself back to here. And now that this method calls every time we push the button on our keyboard or gamepad, we need to do something with this value. And what we're going to do with this value is push it into some type of interact class that'll have some type of functionality of what happens when you try to interact with something. So we need to make that interaction class. We're also going to set a value inside of our character input class that's going to let us know if we're pressing the interact button or not. So if anything else wants to just check and see if we're pressing a button, but doesn't need to fire when we press that button, we'll have this already created for when we need it. But I don't want to just throw it inside of character input, because other things could be interacting with things also. Our enemies could be interacting with things, our NPC characters could be interacting with things, a knife could be interacting with a piece of wood. There's lots of ways that something can interact with something. So how could we create a generic interaction class? That's what interfaces is for. So if we go into our input test folder and to our scripts folder, you'll see we have an eye move input, an eye rotation input, and an eye skill input. All these do is has a move direction that's a vector 3, a rotation direction that's a vector 3, and a skill input that's a boolean of if we're currently using that skill or not. And this lets us build things that can move, rotate, and use skills. But like I said, we also want to create something that can interact. So let's create another one of these. And since I'm using JetBrains, the fastest way to do that is just by typing out public interface I interact input. If you can think of better names for these, feel free to use them. These are just the names that I made for this demonstration. And what the I interact input is going to have is the same as our I skill input. It's going to be saying is interacting, or is pressing interact. So we'll say bool is pressing interact. Then we need to make an open and closed and a get with a semicolon on the end. And this is called a property instead of a variable. A variable would just be bool, my bool, but you can't use variables inside of interfaces. You have to use properties. And to make a variable a property, just make an open and closed and create a get and set inside of it. And there you go, you have a property. But let's get rid of that. We have our is pressing interact, and I said it's faster to create it like this inside of JetBrains, right? How would we do that? Let's click Alt Enter, move to its own class. And there we go, we're done. It's in its own class inside the same folder. Now we can go back into our character input class, and on the end of our mono behavior, let's add the I interact input to this class. Now you'll see that we're getting an error. If you click on what the error is, it'll say we're missing members. So let's implement our missing members. And what it is the is pressing interact button that we created before. Now we can take this property that was added from our interface, which we can access by saying get component I interact input dot is pressing interact. And when we press the interact button, we'll say is pressing interact is equal to value greater than or equal to 0.15. So if you're pushing the interact button down more than 0.15, we'll set it to true. If it's less than 0.15, it'll set to false. The reason we're getting an error is because we never set a setter, and since inside of here we only have a getter, it only has a getter here. But if we make the setter private, we can add a setter on this class no problem without breaking the contract of our interface. And you'll see this error is gone now. Now you might remember earlier I said that we're going to be actually doing the functionality of what happens when we click on our interact in another class. And that was correct. If we click on the mono behaviors folder inside of the same script folders that we're currently in, you'll see we have a commands folder. Opening that up will reveal a few commands. We have an analog rotation, a command.cs, a dash command, an input move command, and a mouse rotation command. Going into the command mono behavior, you'll see that it just has a virtual void execute. That means anything that inherits from command can make its own version of the execute function. So if we look inside of our input move command, you'll see inside of awake we would do what we would normally do. We set up our rigid body and our transform so they're easier to access later. Then we also have these two setups for these two interfaces that I created, an I move input and an I rotation input that we can access with move and rotate. Then inside the execute function that's being overridden from the command we're inheriting from, we just start a move coroutine and a rotate coroutine, which is nothing special. It's just normal rigid body.move position, transform position, plus move direction times time. Time is time.fixed delta time times speed.evaluate. What speed.evaluate is this is an animation curve so that we can keep a steady movement depending on what part of our animation we're in. If you scroll up to here, you'll see it says public animation curve speed. Then we also have our rotate enumerator, which just says while our move direction is not 0, we'll yield return new wait until our rotation direction is equal to 0, meaning we are not touching the rotation stick and we are currently moving. We'll rotate our character in the direction that we're moving by first checking if move direction is equal to 0, continue, because we shouldn't be rotating if we're not moving, so we don't need to fire the rest of this function. That would just be a waste of CPU calls. Then we check the magnitude of our stick, and if it's less than 0.5, we'll smoothly rotate our character to a new rotation using quaternion.lerp and the target rotation, which is just a quaternion.look rotation of our current move direction and vector3.up. Then we do our time again, which this should probably be fixed delta time and not delta time. I'll go ahead and make that fixed now. Then we multiply it by our turn smoothing, and then we multiply it by our move direction's magnitude so that it doesn't automatically jump to 1 if we just slightly touch the stick past the dead zone. Then we set our new rotation to the lerp, our rigid body's move rotation to the new rotation, and if our magnitude is greater than 0.5, we just snap the move rotation to the direction so it doesn't do the smoothing. It looks a lot cleaner, otherwise you have a single frame of it starting to turn and then it snaps to the correct position, which kind of looks bad. So that's all our input move command is. So we're going to create a class that's sort of like this for interacting, but way simpler. Interacts much easier than moving. We can go ahead and close out of this, and inside of our commands folder, we'll right click, add class or interface, and the name of our class is going to be interact command. So the interact command is going to extend from the command class, which means we can override the execute function. And we also need to set a few things up in awake. So let's make our awake function, and let's think about what we need based off what we currently have. So to interact, we probably could use a raycast from our character's position in the direction that we're facing to figure out if what we're clicking on has the iInteractable interface that we created before. So to do that, we need to make a private variable for our transform, and we'll call it _transform. Then we need to make a private iInteractable, the class that we created earlier, and we'll call it _interactable. Then another thing we could need to help on performance is let's create a string for the layer name that we'll be checking against for our interactions. So we'll say private const string, and maybe you want to take this out at a later point because maybe for some reason you need another tag on it besides interactable, so you can't use this tagging system. This is just for performance. It's honestly premature optimization and you shouldn't do it, but we're doing it. And this is actually going to be called interacted with and not interactable because this is going to be a storage of what we're currently interacting with. So interacted with. Now inside of awake, let's set these up. we can say underscore transform equals transform. And now that we have our transform stored, we don't have to do the magic get component call that's hidden behind this word transform. And inside of execute, we can write what's going to happen when it does execute, which, like I said before, we're going to use a raycast to do that. So all we need to do is say physics.raycast, starting from our transform.position plus vector3.up, which is a vector 3 of 0, 1, 0. That just makes the position of our ray a little off the ground since the center point of our character is directly on the ground. Doesn't really matter. You could take the vector 3.up off and it's going to work just fine depending on where your colliders are in your scene. Now we need a direction, and how we're going to get the direction is the underscore transform.forward. Now we need to create a variable to store the raycast hit, so we can say out var hit, which this will create the variable on the same line that it's storing the variable in, which saves us a line of code. Then we need to create a distance that we want to be able to interact with. I'll make mine 2 units. And now we need to call the layer mask that we called a second ago, which we called layer name. If we could scroll back up, we'll see it's called layer name. But we can't just say layer name because it needs to be a layer mask. So we'll say layer mask dot get mask, which will surround with the layer name. Now let's put a semicolon on the end. And for readability, let's do that. So we're saying physics.raycast transform.position plus vector3.up, comma. The direction is underscore transform.forward, comma. We store the hit info inside of a variable called hit, comma. The max distance is 2 units, comma. Then we say layer mask.getMask layer name. Now using the returned hit variable from our physics.raycast, we can say if hit.collider is equal to null, return because we didn't hit anything. And if we did hit something, we can say underscore interacted with equals hit.collider.get component, and the component that we want to get is the iInteractable that we created earlier. Now using the iInteractable, we can say underscore interacted with dot interact. But maybe iInteractable's not actually on our hit.collider, which means this is going to be a null when we call interact. So you could say if underscore interacted with is not equal to null, but as JetBrains Writer is suggesting to us, we could use null propagation, which would just say interacted with dot interact, which means if interacted with is not null, fire interact. And we're completely done with this interact command. But how are we going to actually fire this interact command inside of our player input class? We just created this whole class with no actual way of using it, right? Well, that's where you're wrong. If we go back into our character input script, we can go back to the top of the class and we'll make a couple lines to give us some space, and we'll say public command, which if you remember, that's the class that we're extending from inside of our interact command. So that means we can put any command class inside this public variable spot on our mono behavior that's on our character prefab, meaning any command class that we create can be fired when we press interact. We'll call it interact input. Then using interact input, we'll just scroll down to where we have our on interact button. We'll say if interact input is not equal to null, and we are pressing the button, meaning we push the button down far enough to actually register as what we want our game to be pushing a button as. So we'll say is pressing interact. If both of those fire true through our call, we'll say interact input dot execute, which will fire the command that we just created inside of here, which will create a raycast, shoot it forward, and return whether or not we hit an iInteractable by firing its function. So let's go attach this character input script to our character and attach the interact command script to the character also, and see if we're able to fire this function or not. Let's throw some debug in here to make it easier to see because we don't have movement in. So we'll say debug.log, money sign, open bracket, close bracket, gameObject.name is trying to interact. Then if we did not return null on our hit.collider, we can say gameObject.name interacted with open and close brackets hit.collider.name. Excellent. Let's save and go back into Unity, set these scripts up on our character, and see if it works. After it finished compiling, you'll see we have the interact input area available on our character. We just need to add the other component that we created. So we can click add component, interact command, just drag and drop this into here. Now once we have both these scripts set up, let's go back into the character input script to do one more thing. Inside of onEnable, let's say underscore input actions dot enable. And then inside of onDisable, we'll say dot disable. Go back into Unity, and now we can open up Dynamic Environment, look at our chest, which has a treasure chest, and if we open this script up, you'll see it has the eye interactable that's extended on treasure chest. So since we don't have movement, let's just go to the scene, move it close enough to our character to be able to fire. Make sure our chest has a collider of some sort. It does not, so just add a box collider to it, and make sure the box collider is on the same game object as the treasure chest. Once we added the box collider and edited the size and moved it closer to our player, make sure you raise it up high enough since we changed our debug position to be 1 vector unit higher. Then after setting up the collider, let's go to our layers and add the layer that we said that it's on. So we'll say interactable because it's the interactable layer. Click back on your chest, add it to the layer. We don't need to change the children. Then we can click on play, and when we click down with our mouse, it'll say player is trying to interact. Player is interacted with chest. Excellent. You see it spawned a sphere too, because that's what our chest does, is spawns a sphere. And it's rolling away. It's cool to see that worked. Now we can go ahead and finish the rest of the input script. So inside of here, we can extend the other interfaces that our player should use. If you look over here, you'll see the ones that we're using. We can make this a little smaller. We should be using eye move input because we want to move our player. Eye rotate input because we want to rotate our player. And we'll add eye skill input because we want our player to have a skill. We can implement our missing members, which is move, rotate, and is using skill. For some reason it adds it to the bottom of the class. Let's exit that out and move them to the top of the class. We'll put it in the same place where our other property's at. Then after doing that, let's set up the commands for each of the actions that we want to have, which will have a movement input, an analog rotation input, a mouse rotation input, and a skill input. Now we need to set up the plus or equal to for each of the functions that we're going to have. So we're going to say if we have a movement input command class set up, we'll do input actions.player.movement.performed is plus or equal to onMove input, which we'll create in a sec. Now let's do the same thing for the other commands that we have. We have our analog rotation, which would be the analog aim, and we'll have a function or method called onAnalogAim input. Same thing for mouse rotation input, onMouseAim input. And then finally, our skill input, which is player.skill and onSkill button. Let's create all these functions that we're missing. We can make a little bit of space right here. We'll put it above the onInteract button. We'll call it private void onMoveInput. Then inside of here, we're going to read the value, which is a vector 2. We're going to set it to move direction, which you can see we're getting an error right now. If we go up to here, we can just add the private set, and the arrow will go away. Then if our movement input's not null, we'll execute. Our next one's on analog aim input. So we'll have a private void on analog aim input, and inside of here, we'll get the value, which is also a vector 2. We'll set our rotation direction, which we don't need to have a setter for, because if you go up to here, it already has one. Then after setting our rotation direction, if analog rotation input's not equal to null, we'll execute. Now let's set up the onMouseAim input, which should be the next one. So private void onMouseAim, we get the value. We also set the rotation, but instead of executing the analog rotation, we execute the mouse rotation. You could probably think of a way to set this up to where it only fires the one that you're currently using, but how I'm doing it, you could pick up or drop either one and it's going to execute. They're both just going to constantly work. Now we already have our onInteract button set up. The only other thing we're missing is when we click the skill button. So let's set that up. We'll have a private void on skill button. Inside of here, we'll get the value. We need to set is using skill, then fire skill input.execute. Go back up to here to get rid of the error. We'll put our private set. That error goes away. And we have all of these set up. We have these commands set up. Save everything. Go back into Unity. Let's add the missing scripts that we're missing that we went over earlier. And to get to them, we can go into our input test folder, scripts, mono behaviors, commands, and here's all our commands. The reason it's in just scripts and not in entities is because we can have other things that can have some type of input move command and various things like that. So let's add our missing classes. We need an analog rotation command, a dash command, an input move command, and a mouse rotation command. I'm going to move my input move command up just a little bit just to make it a little more organized, and we'll put our mouse rotation command next to each other as well. Now our rotations are near each other and our input command, movement command is closer to the top, and then our skills at the bottom. This skill one, by the way, is really just an example and isn't how I would do it. I would have some type of skill manager or a skill system or something like that, and not just a single skill class, which I would still have my functionality of each skill does in its own class, but it would be behind another layer of abstraction, not just on a command class. So when we do our movement input, we want to fire input move command, our analog rotation command, mouse rotation, and then dash command, skill input. I'm just going to set up an arc on here. I already have one saved. This last one should work reasonably well. We'll see if it does. Turn smoothing, I'll put it 1 for both of them. We'll put 50 on the dash force and the dash length at 0.5. Now the only thing we're missing is our animation controller, which is not a command. It's just a script that constantly runs and checks the inputs off of our character input script, which we can find inside of Entity, Scripts, Mono Behaviors, and we have our animation controller. We can go to our player and drag and drop this onto here. Then let's open the animation controller up, and all we're doing is getting the dot product between the transform, and we need to get the input's move direction, which we're doing by saying private I move input. We'll call it underscore input. Then we need to set up the input inside of awake by saying underscore input is equal to get component I move input. Then we can just say input dot move direction. And once we get the vertical dot and the horizontal dot, we can just set it to our animator. So we're always doing the correct animation based off of where we're running. Let's go back into Unity and click on play and see if everything works. So we'll click play. Everything does work, except our camera's acting wonky. Leave play, and let's change some values on our camera. We'll change the binding mode to say world space. If we click play, you'll see that the character is always facing our mouse direction. And if we use the analog on our gamepad, it does nothing. Let's do some debugging and try to figure out why that would be. So our analog rotation command doesn't seem to be working. Let's go into our analog rotation command. After glancing at it for a minute, it seems like everything should be fine. So let's go into the only other place where it could be, which makes more sense because we're constantly looking at the mouse when we should only be looking at the mouse when we click a button down. So there must be an error inside the mouse rotation command script. So let's go inside of here, and you'll see right here I have interact.isPressingInteract commented out and replaced with true, which is going to make this always true instead of only true while we're pushing the interact button. Then when we uncomment it, you'll see we get an error. If we scroll up, we just need to uncomment this and uncomment this, save, go back into Unity, click play, and see if everything's working how we expect it to. Using the gamepad, I'm walking in the direction that I'm telling the character to walk. Using the aim, I can change his aim direction. You can see it's really jumpy looking, and so let's try to debug why that could be. Let's go into the player input actions and look at what happens when we use the gamepad. You'll see here, it's also digital normalized, which means it's always a 0 or 1, but we want it to be analog. And let's check the other places where we're using gamepad, which is in our aim, where we also want it to be analog. And everything else should be fine. Let's click Save Asset, wait for it to recompile, click on Play again, and you'll see our character moves smoothly now and rotates smoothly. And we can switch between the keyboard and the mouse without any issues. We can walk up to our chest, interact with it, and after our allotted time, a little sphere plops out of it. Now, let's see how powerful this system really is. Let's add all these scripts to these enemies and see if we can get them to walk around and how long that's going to take. So let's go to our enemies. We have our character here. Let's add the scripts we need to add, which is we'll have just an input move command and an animation controller. Now we need to create its own custom input script for passing the inputs into those other classes. So let's go to Entities, Scripts, Mono Behaviors, and we'll create C# AI input. Once that compiles, go to your enemies and we can add this new script to them. After adding it, go ahead and open it up. Then we can get rid of the start and the update. Let's put it in its correct namespace. We'll say public command, move command, and now our AI input's going to have the I move input and the I rotation input. Let's import our missing variables or our missing properties. Then let's re-add the start function that we just removed. Inside of here, we'll say move direction is equal to new vector 3, and we'll just say 0, 0, negative 0.25f. Put a private set on our movement direction. Then after doing that, we're going to say move command dot execute. Then let's create an invoke repeating. Let's create the function that we want to repeat. It's going to be called void change direction. So we'll say name of change direction. We'll do it after 1 second. And the repeat rate will be random.range, so it'll be different for each unit, and we'll pass in 1 to 4. Now inside of change direction, it's just going to say move direction is equal to new vector 3. Pretty much the same thing as what we have here, so we can just copy, paste, clean it up, and then we'll change this to be random.range -1 to 2 divided by 4, and then we'll put the same thing here, and then change the 4 to a 0.0f, because we don't want to lose our fraction, 0.0f. Let's take a look at the whole class now that we're done. Save, go back into Unity. Let's set up the command, so let's click on all 3 of our characters, which won't work, so we need to do it one at a time. Input command. If it was a prefab, this would be a lot easier. Oh, it only has it on 1 character. Adding it to multiple did not work. Alright, input move command needs to go on these other 2, which I'm not going to do that. I'm just going to delete these. We'll set this guy up completely. Then we can go to our prefabs folder, drag in rename this to enemy, drag it into here. We'll make it we'll do it in original, because you should probably be a different model in another game. It probably wouldn't be a variant in a normal game, so we'll do original. Now that we have him set up, we can duplicate him, go to our scene, double click to get to him, move him over, duplicate again, move him over, go to the game, click play, and bam! We have AI set up, and it only took like a couple lines of code. So I hope you can see the power of using a system like this to do your inputs, and why the new input system is a great change for Unity 3D. Restart it just to make sure everything works nice. And that makes the end of this video. If you're confused about anything, you can leave a question in the comments below. I really hope you enjoyed this video. If you did, consider liking and subscribing to the channel, and leave some comments on the video to help the YouTube algorithm to think you enjoyed the video. Oh, and I also never showed off the dash, so let's do the dash real quick. The dash works too. One other thing you could do is make the command class an iCommand interface, and instead of passing them through the inspector, you could add another layer to the system that injects them in, or just create them inside the awake method, passing their dependencies into the constructor. This would make the commands easier to use for other parts of your application that doesn't use mono behaviors. Some other useful things you could look at with the new input system is the entire new input system manual, where you can find out how to rebind your inputs using UI, create custom interactions, inputs, and bindings, and even how to migrate from the old to the new input system. But that's it for this video, and I really hope you enjoyed it. If you did, like the video, and maybe leave a comment down below. I also have a Discord channel you can join. You can find the link to that in the description below as well. And as always, all the source files for this project are also in the description, so don't forget to like and subscribe to the channel. As always, have a wonderful day and stay coding.